Hello everyone, welcome to the first lecture of Amplitude Modulation. In this video, I'll discuss about the basic concept of Amplitude Modulation. But before that, let me first explain this four topic so that you can understand about Amplitude Modulation very easy. The first is, what is communication? Communication is the process of transmitting our message from one place to another place, or communication is the process to share our idea from one person to another. Communication can be two types, either wired or wireless. In both ways we can communicate to each other. For communicating our message, we need a message signal. There are three types of message signal. First is voice signal, who's in the range of 300 Hz to 3.5 kHz. Audio signal, range 20 Hz to 20 kHz. And another way to send our message is the video signal, which is in the range of 0 to 4.5 MHz. Now, the second point is need of modulation. What is the need of modulation to share our information? As we know that our voice signal, which is in the range of 300 Hz to 3.5 kHz, which is very less to transmit this signal in wireless. So there is a need of modulation. We know that for propagating our signal through antenna, the wavelength of the message is lambda by 4, and generally we send 15 kHz of a signal. So if we calculate the height of the antenna so that we can propagate our message, it is C by F, where C is the velocity of the light and F is our frequency. Wavelength is lambda by 4, so 3 into 10 to the power 8 divided by 4 into 15 kHz, 15 into 10 to the power 3, approx 5 km, which is impossible to install that much height of antenna. So we use here the modulation concept, in which we introduce a carrier signal. The range of frequency of the carrier signal is up to megahertz, and if we put 15 kHz signal which is replaced to in range of megahertz, then this height of antenna, which is reduced kilometer to approx meter range. It is a very easy mathematics here. 3 into 10 to the power 8 upon, if we use 1 megahertz carrier signal, then 3 into 10 to the power 2. Right. So 5 kilometer and it's approx 300 meter. So, and if we use 5 megahertz, 10 megahertz, then the height is another reducing. So we can say that if we increase our frequency, then height of the antenna will reduced. Another use of modulation is multiplexing. Okay, as today's scenario, there are a lot of congestion in data traffic, so we can transmit multiple signal rather than only single signal. So, and another important thing is multiplexing is not possible without modulation. This is not possible. So, to use of multiplexing means to merge more than one message signal in one carrier frequency. So all that stuff is used with the help of modulation technique. Now the next point is types of modulation. Of course, there are two types of modulation. The first is single tone, and the another is multi-tone. If in in our message signal there are only one frequency component are there, then it is single tone modulation. And if there are more than one frequency component is present in our message signal, then it is called as multi-tone modulation, which is clear in this example. Let me draw the diagram of this. This is our message signal FM, and if only one frequency component is there, let me omega 1 minus omega 1, only one frequency component, then it is called single tone modulation. And if our message signal like this, minus omega m FM. So you can see in this picture that there are multiple frequencies are present. So this is called multi-tone modulation. Okay. Till now we discussed about modulation, what is the concept of modulation, what is the type of modulation, but I do not tell you about what is the definition of the modulation, right? So we can say that modulation is the process in which one of the parameter, that is amplitude or frequency or phase of the carrier signal, is varied according to the message signal. Fine. Let us discuss some more concept about modulation. Let us take a message signal. MT is equals to this is my message signal MT minus F to F. Okay, and another carrier signal CT AC cos 2 pi FCT, where FC is the carrier frequency. Okay. This is my CT. The Fourier transform of this carrier signal is AC by 2 del F minus FC plus del F plus FC. Sorry, no plus. Okay. Now we have to merge this signal with this carrier frequency. It means ST. ST is what? The modulating signal. Modulating signal is nothing but MT into CT. MT is our message signal, CT is our carrier signal. When we merge this two signal, so what we get? This is our CT, and after merge this signal, this is our MT minus F to F. What we get? This is F plus FC. This is F minus FC. This is minus F plus fc, this is minus f minus fc. Okay, now what is this and what is this? This is the sideband of our resulting signal. 99% of the message is stored in the sideband only. From where you get, it comes with the help of Fourier transform. As we know that the Fourier transform of CT is AC by 2 del F minus FC plus del F plus FC. So after we all know that it is the transform that convert the time domain representation into the frequency domain representation, and with the help of this transform, the spectrum analysis of our resulting signal is like this. This is the sideband. This is the upper sideband. So lower sideband. As we know that the maximum 99% of the information is stored in the sideband only, and this is very important figure, guys, because with the help of this picture we can divide our amplitude modulation into 4 different types. What is that? First is amplitude modulation itself, another is DSP SC, double sideband suppressed carrier, third one is single sideband suppressed carrier, and fourth one is vestigial sideband. In double sideband suppressed carrier we use these 2 sidebands. In single sideband suppressed carrier we use only one sideband of the carrier signal, either this or this. So I will discuss in detail about these 4 classification also. So that's it for today, guys. In the next video I'll discuss about this 4 modulation technique in detail, how it can be generated, how it can be demodulated, what are the advantage and disadvantage of these all 4. Thank you. Thanks for watching in this video, and if you have any doubt, do let me know in the comment section, or you can message me in my Instagram ID that I'll given in my description box. Okay, thank you. Thanks for watching. I hope to see you in my next video. Thank you.